Hi, my name is Emilie Green. I'm a second year PhD student at the University of Aberdeen. And today I'm going to be sharing with you my research project, Chronology, Climate and Resilience, constructing a multi-proxy Bayesian chronology of Bronze and Iron Age nomadic pastoralist responses to dynamic steppe environments and landscapes in Northern Mongolia. So just some general background about my project and the research itself. So I'm currently working with Professor Paula Reimer and Dr. Joshua Wright on the Chronology and Changing Cultures on the Mongolia Steppe project. This is a joint project between the University of Aberdeen and Queen's University Belfast, and it's funded by the Quadrat DTP Doctoral Training Partnership, which is a NERC UKRI DTP. And also the project is partly funded by AEA, and the overall aim of the project is to refine the chronological periods of Mongolia through the production of an extensive suite of new AMS states from changing monumental subsistence material, social and political changes within Mongolia and the Acknowledgments area of Mongolia can be synthesized and examined. Oh, sorry, just realized I hadn't switched to the next slide. There. Okay, so the research I'm presenting today is as part of this project, and it consists of two main facets. So the first of these is chronological modeling for the generation of an extensive suite of new radiocarbon dates, and Bayesian modeling for dates for the Acknowledgments area of Northern Mongolia. And also the second part of this is reconstructing climate and environments of localities within the Acknowledgments to examine human responses to change. In this research aims to explore how nomadic pastoral communities of Mongolia adapted to the dynamic and changing environments of the Eurasian steppe during the Middle Holocene and the Bronze and Iron Ages. And this will be done through the examination of the relationship between communities occupying this area and their environment. And this will be done through the generation of new chronological data, paleoclimatic data from proxies, and a compilation of legacy dates and environmental records. And through this, we seek to test to what degree we can examine the ways in which pastoral nomadic communities in Mongolia adapted to the changing and the dynamic and changing environments of the Eastern Eurasian steppe during the Middle Holocene and the Bronze and Iron Ages through proxies. So we hope, through examining the dynamic between culture, chronology, and the environment, this will enable us to better understand human environmental interaction, both on a regional and a local scale. And we're looking at strong emphasis on localities within that. The chronology of Mongolia is traditionally considered as homogeneous, but in recent decades, there's an increasing picture of cultural complexity emerging, both within Mongolia and wider Eurasia. With the lack of sedentary sites available to us in the Mongolian archaeological record for these periods, piecing together the chronology and cultures of Mongolia and the Eurasian steppe has presented great difficulty. So we aim to examine identification of events happening with the archaeological record through the construction of these chronologies, and when can we see shift in fodder practices in our data set? How does this correlate with current perspectives of emergence of pastoralism on the steppe, and what changes do we see in diet? Is this a result of changing subsistence practices or other factors? And can we see the inclusion of millet? Again, how does this relate to current perspectives on chronology? All of this we hope will allow for the contextualization of key changes in the archaeological record, and it's anticipated that moments of change and possible cultural subsistence adaptive strategies to change within this area will be identified. So stage two of that is in an area where direct paleoclimatic data is limited and where existing data is generalized with major disparities across the different regions of Mongolia, And we hope to use stable isotope and to offer a novel approach to examine human environment interaction in greater detail. Just a bit of context. The Mongolia encompasses a range of dynamic and changing environments and landscapes, and we hope through examining the chronology for the adaptation of pastoralism in Mongolia, alongside directly associated environmental proxies, that this will give us a two-way perspective into human environmental interactions within nomadic groups. And part of this is examining data not only for any signals we might see that indicate general climatic trends, but also how these shape cultures, but how the advent of pastoralism and later agriculture has impacted the environment. So our study area is the Acknowledgments River. It's a tributary of the Salend River drainage basin, and it gets its headwaters from Cusco. Just to contextualize the area for you, it's within a broad valley basin, which is archaeologically very rich, and it represents a period of 30,000 years of human occupation. In the 1990s, the area was heavily surveyed as part of a joint effort between the Mongolian and American research teams. So for our materials, we've currently got 120 human and animal samples, including horse, cattle, and goat and sheep. So these come from across 15 different sites within the Acknowledgments and neighboring areas. For these samples, we hope to, we have been radiocarbon dating them and submitting them to carbon nitrogen stable isotope analysis, and also sulfur. We're conducting the sulfur analysis of samples across the distribution of high value carbon values and nitrogen values and low carbon nitrogen values. So within Mongolia itself, when we look at the environmental records, we see that across Mongolia, disparities exist across the climatic and environmental record, both spatially and temporally. And the nearest paleoclimatic records for the Acknowledgments area at present are taken from Lake Cusco and Lake Baikal, both of which the Acknowledgments is connected to. But as you can see from these graphs, the red arrows indicate that Lake Cusco. But yeah, this kind of demonstrates that disparity. And also what you might notice is that the resolution for these environmental records for thousands of years and kind of do not provide enough nuance to kind of explore these human environmental interactions on kind of a higher resolution, maybe from generations or even year to year. So it kind of misses the nuance of understanding the context of this relationship and how they were directly responding. So in this project, we hope to refine the timings for events, and we hope to do this through Bayesian chronological modeling of the new and legacy radiocarbon dates. And also we wish to do a cross comparison of published environmental data for the region against the stable isotopic data we are using as proxy, and kind of looking, does the environmental data that we have which we can infer from the stable isotopic data, does it fit these regional trends that we're seeing in these earlier environmental proxies and data? And if not, where do we see more disparity? And does it highlight more disparity? Yep, so this project has not been without its difficulties. It's with Bayesian chronology, it relies heavily on archaeological prior information, and this is usually in the form of stratigraphy, typological dating, and things like that. But what the issue we have in the Acknowledgments, and particularly Mongolia, is that there is a lack of stratigraphical information just due to the basis of how these sites are excavated, the nature of the sites, and they're very much assumed to be singular events, the construction of these monuments that we're dating. Yeah, and obviously for Mongolia, the freshwater reservoir effect for radiocarbon dating is not clearly yet understood. So we're not sure whether the individuals that occupy this area are consuming riverine fish, which offset these dates. And yeah, and also the sampling strategies and the excavation methodologies have caused difficulties with constructing chronologies as well, because yeah, it's very random sampling. So you cannot have like a very robust model. You kind of have to, a lot of consideration has to go into how you're going to refine your model and how you're going to constrain your model to get this robust chronology. So yeah, from early pastoralist to the Iron Age. So these are the chronological periods that we will be examining in this project, and these run from there's a few dates in the Neolithic, from the Bronze Age all the way through to the medieval. I won't get too much into the contextual information of these periods, but basically a lot of these periods, rather than being considered archaeological periods and cultures, they're monumental traditions. So as you can see here on the images, there's variation of monumental traditions, and this is how the archaeological record of Mongolia, and specifically this area, has been contextualized. So yeah, our research area. So yeah, this is the Egingol. And as I mentioned earlier, it was a wide river valley basin, and it has the remnants of ancient terraces between elevations of 840 and 900 meters above sea level. Yeah, and it's flanked by steep sides of eroded mountains, and it's the forest steppe bordered by subtaiga taiga. And that's just some information to kind of contextualize what we would expect to see in the environmental proxy data. So we have currently begun stable isotope analysis, and this is kind of our initial results. And as you can see here, generally the delta nitrogen values show that humans are likely eating sheep and other terrestrial fauna. So this appears to be no inclusion of riverine fish. There is an enrichment of delta carbon values, and this is thought to likely indicate a more open steppe-like environment rather than wooded. If you remember a minute ago, the current environment of Egingol is this forested taiga, subtaiga. So it's likely that it was different during this period. And the enriched delta carbon values we see in early late Bronze Age samples, this is more likely to signal environmental variation rather than in later samples, which is likely to signal the introduction of C4 plants, likely millet, this could be possibly used as an event to identify the inclusion of millet in diets. But like I said, this is just initial analysis of these results, and further investigation needs to be done. So yeah, also we currently have data for sulfur, and the initial observations of the stable sulfur data show us that the delta values for sulfur, from these we can infer that animals lived in a terrestrial area, most likely with no marine or freshwater inputs, but this is still to be further tested. Analysis of more samples need to occur so we can confirm this. Yeah, and a sulfur isoscape needs to be created to see if the scale of sulfur differences is significant enough to show mobility. And but as you can see from the graph, that a majority of animal groupings are quite close together, and when you consider the range of terrestrial sulfur. Yeah, so we've begun constructing the chronology for the Egingol from our radiocarbon dates, and so far we can see that The model dates, again, at present, there's no constraints on these dates because it's been really hard to use prior information to constrain these dates because of the lack of stratigraphical and sequence data. So at the minute, what we can see though is that the model dates fit expected start and end dates from 3,350 to 2,800 BP. And only 2 dates lie outside of this expected range. We're not sure why these dates lie outside of this range, but we need to investigate this a bit further. And for the slab burials, again, we see that the dates lie extremely far out of expected date ranges. And we're exploring the possibility of, is this a later introduction of slab burials into this area? But as you can see, this is a very limited model at the minute. There's only a few dates, and we need a lot more to refine these models. Oh, wait. These are the slab burials, sorry. Okay, and also we've modeled for the Zhongyu period, and again, a lot of these dates lie within expected ranges, but a little bit later than we expected for the Egg and Gaul. And a number of these dates lie outside of these expected ranges. Yeah. So for the Turkic and Mongol period, model dates for the Turkic period lie within expected ranges, but for the Mongol period, it's kind of either end of these expected ranges. And again, we need more dates to refine these chronologies. And also, again, further work needs to be done for kind of the parameters to refine these models. Yeah, so next steps. So at the minute, we need to generate more AMS dates for slab burials, Turkic and Mongol monuments to better understand these periods. And then we need to compile a model that employs both new and legacy dates for the Egg and Gaul and wider Mongolia, because at the present, we've only used the new dates to kind of explore initially kind of what time periods we're seeing. And we need to combine this chronological information with a more in-depth analysis of the carbon, nitrogen, and sulfur data to examine these environmental signals by period. Because at the minute, as you've seen, we're very much kind of just examining the data and just to see what patterns we see, but there needs to be more in-depth analysis of that and kind of in order to reconstruct and infer environmental signals that might be occurring. And we also hope to conduct stable oxygen analysis on equine samples from our best understood site within the Egg and Gaul. And this is hoped to further refine this resolution of environmental data to reconstruct seasonal temperatures at site level. But this very much at the minute is dependent upon getting extra funding. But yeah, just so to summarize, chronological modeling of AMS dates from burial context along the Egg and Gaul River, Northern Mongolia. And within this, we hope to refine chronological period start and end dates so that we can better understand the specific events, not only across the wider region of Mongolia, but at localities, and the specific emphasis on localities and how building from the smaller picture up rather than the bigger picture down. We've examined stable isotope data, and we hope to use this to infer environmental change, but this needs to be more closely examined at this time. And the main kind of thing is we hope to bridge gaps in the environmental records for Mongolia, both spatially and temporally at a higher resolution, of both of these means. And all this, we hope to build a more nuanced model for cultural change and an adaptation and the emergence of pastoralism and how nomadic groups respond to environmental change and overcome and adapt to these changes. And through this, better understanding of the environments and climates of Eurasian landscapes, and we hope to contribute to pan-Eurasian narratives of human adaptation and resilience throughout the Holocene. And and finally, there's a lot more data to come. So just acknowledgements, I'd like to thank all of our Mongolian colleagues from our Mongolian institutions and colleagues at the Chrono Centre at Queen's University of Belfast, and AEA and UKRI for making this whole project possible. Thank you.